5G, very hot topic these days, and I wanted to introduce our next speaker. Unfortunately, Dr. Chiueh could not be here, but Dr. Wang is more than capable of talking about 5G, especially when it comes to AI. Dr. Wang is the Division Director of Data Center Architecture and Cloud Applications. He's also in charge of the IC Labs at ITRI. He's had more than 20 years of experience there. He's server and networking architect as far as it relates to system software. He's designed several cloud data centers and has literally done that in Taiwan and across the globe. Please help me to welcome Dr. Wang.
Okay, thank you. Okay, here's my topic. I'm Chiueh Wang, the Division Director of the ITRI. I apologize for change. Since Dr. Chiueh, he had something happen and his flight was delayed. Actually, he's now still in China, so he cannot make it. So I will do my best to deliver the presentation. So this is my topic, AI edge computing. So first of all, I will give you a definition about what is edge computing. According to Gartner's definition, the edge computing is a part of distributed computing, distributed system, and it performs the information processing and close to the edge or close to the server user. And what is the part of distributed computing? It is needed to connect to the cloud or to a central controller. It is not a standalone system. If an edge system is still a standalone system, it is not called edge computing or edge system because it did not provide more features than the standalone systems. So for the first of all, it should be a part of distributed computing systems. And it is process the information processing. It is either for the just filtering or aggregation, or maybe as complex as a machine learning or data analysis. And the processing is close or located close to the user, close to the edge. And what it means, the close, it's just a subjective term, and maybe just a handset held by a user in the same room, in the same building, or even in the street or urban city. So it is just a related term. So anyway, it's just close to the edge. So by the definition, the edge computing is not competitive or mutually exclusive to the cloud system. It is complementary. So this is what we understand about the edge computing. So compared with the cloud computing, the edge computing provides more response, little response time and little jitter and quicker and real time. And maybe the architecture, actually the architecture is, cloud is centralized and edge is decentralized. And the process location maybe just within one hub of network hub. And compare with the cloud computing, it may be multiple hubs within the network. Yes, so this is the comparison. I would like to give you a feeling about how much it will cost just buy a camera. The camera will cost maybe just 10 or 12 US dollars. However, if we just send the raw data onto the cloud, actually for the 3 years, it will cost 1 million US dollars, huge amount of money. So it is not impossible. So even we reduce the frame rate, it will still cost high. So it's better to compute the data just in the edge. So we have a lesson that it is unreasonable to send this large amount of data to the cloud So it's better to process the data locally. And actually, in most situations, we have the data privacy, we have the security. So this is why we have the edge strength. So even for the cloud giant, such as Microsoft, AWS, Google, they are pursuing the business opportunity of edge computing. So let's see the market opportunity. So this is edge computing, the growth rate will be more than 20% per year. And for the AI in computer vision is 40%. And surveillance video analytics will be 20%. So the market or the business opportunity will be the AI plus edge computing. So we would like, what is the AI edge computing? Of course, it was connected by the network, maybe better for the 5G, so it will have high bandwidth, low latency. And we have so-called edge data center. Actually, the edge data center, the scale may be just not large, maybe just very, very, very small. And the target application will be the deep neural network-based video processing. So this is our focus on the, actually it is the mainstream so far. So it is AI. So compare with the model training in the cloud, basically we use the edge computing, it is for inference, model inference, to predict what will happen. So for your model, it may be generated or trained in different frameworks such as Caffe or TensorFlow or PyTorch. And most of the situation will transfer to a standard model, standard format. It's called ONNX. It's the standard format. So in terms of, we need to run the model in different target, hardware target. So we need, the different vendor need to have their tool to transfer the standard format, ONNX standard format, to their specific format. So they need to provide some tools to transfer the model. However, the resource is limited. So the tools, most likely, they need to provide some function such as operating fusion or quantization, or to map the instruction to the specific hardware accelerations. So this kind of tools. So Entail OpenFino, it is a tool to provide, to transfer the model into the Entail Morpheus, maybe FPGA, or even their CPU. The performance is very good compared to the original model. They provide maybe this speed up inference can be, the performance will up to 10 to 100 times. And the Google TPU, Google TPU is for inference processing, and it is an architecture just using the systolic array architecture. The systolic array architecture is proposed by H.T. Kong. It is proposed in 1979. It's extremely amazing. The concept is proposed 40 years ago. The concept of systolic arrays, that the data can be read once and compute many times. It will go through multiple computation units. So that's why this kind of architecture can provide a very good performance under limited resources. So that's why Google used this kind of systolic array architecture to implement their TPU. So this is for inference. It will provide high performance within limited or restricted hardware resources. And we need to connect our edge devices to the cloud. This is Amazon Deeplans and connect to their cloud. So they provide this green grace so that the data can be collected in the edge and send to the cloud. So this is why that this kind of cloud giant, they provide some kind of tools to help the industry to implement their edge. And the most important is that the data should be sent to the cloud. Of course, it is not necessary to send all the data to the cloud. Maybe the data can be processed in the edge, or maybe the data will be sent to the cloud. In some case, maybe we just capture a full frame and we apply the object tracking and to crop the area we concerned, and just crop some small of the data and send to the small area of the full frame to the cloud. So the communication cost will be reduced extremely. So, so this is this kind of edge computing. And I would like to give you some example of the edge computing examples. The first of all is the intelligent video surveillance. You can apply the virtual borderline. If somebody or some object cross the line, you can send an alarm to the system. And you can apply maybe children or elder monitoring to detect the fall detection. And you have parking lot management. And you have the smart hospital. You can monitor the patient activity. And in some case, you can apply the face recognition to recognize the face of the patient or the visitor. In most cases, people in hospital, they will wear masks. So you can apply the face recognition to recognize the face with or without the mask. And you can use the AI-based medical image analysis. User can upload their DCOM, which is digital image for medicine data, up to the platform, and you can detect the cancer. The detection accuracy rate will be more than 90%, so which is very good. And we have next generation smart retail. It is just like Amazon Go, and it can detect the shopping area. You have the heat map, so you will know which area of the shopping area is more famous. And basically, this kind of system will answer how many shoppers and each shopper's trajectory and which merchandise is looked or is touched, or does she like or dislike it. So in some case, maybe you just sit in a restaurant and you just wave your hand to call and raise your hand to wave again and again to call a waiter. However, there's no waiters come. So in this system, you just raise your hand and the system will know your intention and call a waiter, inform the waiter to serve you. And the smart manufacturing will basically this help the AOI defect detection. It will provide more high performance, maybe 10 times performance, and extremely low false negative rate. So in this kind of application, we need a system. So we call this AI edge computing for video analytics. It is, this is the building block. We have the CPU, we have the GPU, and a small set of servers, maybe just 10 servers, or you have 100 GPU cores. And in some cases, you will connect to 5G. And with multi-tenancy, I will explain it later. And actually, in some cases, we have server or we have just gateway or router. So maybe we have the GPU, server's GPU, or maybe we just have the very limited resource GPU, such as Entail MorphiDias, such that, just like that. And so this is building block of the AI edge computing system. The most important, I think, is the ONN Model Compiler. Since you need to provide many kind of hardware accelerators, so how can you to develop your model to support this kind of so many different kind of hardware accelerator. As I said, different vendors need to have their own compiler to convert or transfer your model onto their hardwares. So in your development environment, it's very complicated because you need to have different versions for different hardware combinations. So to support a compiler for many different hardware is very important. And you have many DNN models. However, in the edge, the resource is limited. So we need some kind of optimization to speed up the DNN model execution or inference. So as I said, that in the edge, the quantity of the server is just small scale. It may be just 10 or 4 set of servers. So basically, you can connect this server with a very high bandwidth bus, such as PCIe, to support the very high bandwidth, low latency, and actually you can support the concept of resource disaggregation, such as GPU sharing. So this kind of system, just like the OCP, this is a joining concept, just the OCP accelerator modules. And as I mentioned, the DNN compilers. Okay, for my personal opinion, the DNN compiler, there's a very good generic DNN compiler is called TVM, and the other is the GROW. TVM, actually it is originated by Washington University, and now it's hosted by AWS. And the GROW is hosted by Facebook, which is announced or published in the OCP summit in March this year. So in TVM, it supports a very high, very good optimization for the DNN inference. So the speed up is very good. And this is for TVM. And for the GROW, it will transfer the model into the intermediate representation. And then for the bottom layer, it will transfer the model or the instruction set onto the hardware-specific instruction. So in order to transfer the model into the intermediate representation, there's 2 layers, general optimization and the feature-dependent optimization. So the concept, it will perform the optimization as high as possible, so that it's just to produce some small set of instruction. So the hardware just can support limit set of the instruction, just such as algebra instruction. So a single compiler can support many kind of hardware accelerators. So this is very important in terms of the model developer. So you can find out the TVM and GROW. I think it is very good. Of course, still different hardware vendors still have their own tools, maybe provide better optimization, especially for their hardware. However, in terms of software development, it is very important to have a single configuration. So maybe you just want to have the compiler for all hardware accelerators. And we like to optimize the model. If you have multiple models, how can you optimize it? Maybe there's one way is you have data and go through all the model before it went out to the GPU or CPU cache. This is the method. And another method is that you can retrain the model to share the feature extraction. So that conceptually, you have 10 models and you retrain it to become a single one. So this speed up with 10 times. So, and with resource management of DNN model execution, basically, we apply the DM model to inference on a stream on a video. There is no need to inference the frame by frame. So there's basically you just apply the inference, full inference on the first frame, and you will find a relationship between the frames. So for the next frame, we will perform the next feature extraction. So still there's two methods to speed up this kind of feature extraction. You can perform the feature extraction, full feature extraction on the first frame, and you can some concept of optical flow to the next frame. So basically the optical flow will perform faster, so you can speed up. And actually, in some cases, you can have the different feature extractors for long feature extractor and short feature extractor. However, you can apply LSTM, which is the memory. You memorize it, so you know the features and memorize it, and later you know what it is, so the performance will be better. So, and we can have so-called operating system for the video model executions. You can have different models in version 1, version 2, version 3. Version 1 maybe provide high quality, however, it needs more resource. And version 3 is low quality, however, it needs less resources. So in many cases, we just apply the high quality. However, in some cases, we have the limited resources, so we apply for low quality. So even in some cases, we just skip up it. So this is kind of model executions. And I would like to give you some concept. Since the edge computing maybe need to provide multi-tenancy. So there's this concept of hardware as a service. I would like to explain what is hardware as a service. You maybe know the co-location business, and you also know the IaaS, infrastructure as a service. So as a co-location, the service provider, just the rental model is the rack. So the machine is prepared by the user. And for the IaaS, the machine and hardware also prepared by the provider and managed by the provider. The user just get the virtual machines. However, in terms of the hardware as a service, user get a physical servers. So why we need the hardware as a service? Because in some cases, you need a higher performance. So we take care about the more efficient utilization of the hardware resources. So maybe container-based virtualization is good enough. So you just get the concept that user get the physical data center instances. So user get a server storage. However, let's share the same network infrastructure. I will mention it later. And we need some tools to remote manage this kind of servers, such as OS, install OS, install update BIOS. And so user got many servers, got some storages. However, they share in the same network infrastructure. So it will cause some problem. So we need to provide some network isolation. So basically, we just set the VLAN onto the switch. However, the user come and go frequently. So we need a dynamic VLAN setup utility for this kind of situation, for this kind of management. So this is a hardware as a service operations view. Just for operators, for a service provider, you have a bunch of servers, and for some user, they rent some server, some storage, and the process is just the user got some server list, and they need to perform the BIOS or BMC update, maybe for security issues, for newer features, and they will select OS configuration and to select these images so that they can remote install their OS or update their BIOS to the servers belongs his own. So this kind of tools is very important for the users, especially for edge. Basically, we have many edge on the different locations, so we need a tool to remote management such large quantity of the edge servers located in different locations. So this is the experience from KDDI. KDDI is Japan, the second largest telecom company. This is their experience. They provide 200 times faster than the manual operation. So in terms of the manual time, is the time you have, for example, you have 80 servers. You need 300 man hours to complete the operations. However, using this kind of tools, you just need 1.5 man hours. Actually, for these tedious tasks, maybe it is not such time-consuming to do these tasks. The most time-consuming is that you have an error, find an error, and fix it. So it is very time-consuming. So you need a tool to automatically do the job, do this kind of tedious job. Again, in terms of edge computing, you have many servers in different locations. So we really need this kind of tools to automate the edge computing management. So I just give you some concept of the AI edge computing system, DN training appliance, and application-specific DN and inference, and some concept about the optimization tools. And so this is my presentation. Thank you.